All right, hello everyone. This is Unit 1, Lesson 3. This is almost like a unit within a unit because we're going to step away from the charts and graphs and descriptions of those for a couple lessons and look at just a bit of an introduction into experiments. So, in this next two lessons, Lesson 3 and Lesson 4, we'll look at some interesting ways that we can piece together what is a statistical experiment. And in the next lesson, we'll look at sampling because, well, sampling is going to be important to give us good data. So, first we looked at the data. Now we'll look at ways to collect the data. And then later on, we'll expand upon this even more in order to create uh, a full group of techniques in order to perform a full research experiment. Okay, so we are going to start with a little bit of a description on what a good experiment or a statistical study, I should say, looks like. And they could come in either observations or experiments. So here are some questions that we hope to answer over the next couple lessons. So, uh, what are some statistical ways that we could choose to study a situation? We can also look at how we actually conduct a statistical experiment from start to finish. And later on, how do we choose a sample? Um, so, are there better ways to accomplish this than others? And the short answer is, of course. Uh, but there's lots of good ways to choose a sample. And some ways are good in some situations and some are not. So, just like anything else that we've discussed so far, there's going to be some interpretation and there's going to be situations that are not don't fall neatly into one category. And it's up to us to decide what's the best plan of action in any given scenario. Okay, so let's look at one particular study that could be performed. So, suppose we read a study that says that students will have a GPA 6% higher if they eat breakfast before coming to school than if they do not. Okay, so how do we reach that conclusion? Well, so the general idea is a researcher follows 704 students for 2 years of high school. Their GPA was measured before the study and again at the end of the study. So this sets a baseline for each particular student. The students that eat breakfast on a consistent basis were found to have a 6% higher GPA than those that did not. Um, Now, what's not clear here, just simply based on the wording, is to whether or not it's 6% higher GPA altogether or whether it's 6% higher GPA growth. I'm guessing it's just all together. Now, the question is, what does this tell us? Is this legitimate? Does this suddenly mean that, hey, breakfast is great? Well, we all know that breakfast is great, right? I mean, a good bowl of Wheaties before you come to school in the morning? Sure. Maybe a couple Eggo waffles or two? Excellent. Now, yes, that means you actually have to get up out of bed before 7:30 in the morning or 8:10 or whatever it is you guys get up now. Um, hey, I'm not complaining. Don't look at me. I get up at 5 a.m. every day. I have plenty of time for breakfast. So, um, no, it makes sense to think that breakfast is, you know, a contributor to having a higher GPA. But is it the only contributor? We have a lot to examine to understand if that's really true or not. So, we're going to refer to this a few times throughout this lesson. Okay, so let's get down into the actual two types of statistical study. There have what we call an observational study and then an experiment. Okay, so the difference here between the two revolves around the role of the people actually conducting the study. Okay, so just some quick notes here. I'm going to explain all this on the next few slides. Um, but the key here is that with observational studies, think about the word observe, right? For experiment, think about an experiment like you might have done in science class, like with a lab. And in a lab, you have controlled situations and you are actually performing things. You're given directions, you're performing different tasks to ascertain if there's a difference. Like, a good example is, of whether or not like different contaminants in a petri dish lead to higher bacteria growth. We can set that up as an experiment as we would in science class. But then there's an observational study as well. Okay, so these are two main types, and depending on the kind of study, you are going to handle and be able to conclude different things depending on what kind of study you're doing. So the math will be different between the two. The conclusions will be different between the two. So an observational study, okay? In an observational study, you are simply observing characteristics of a sample. Now, again, there's that base word observe. The person conducting the study does not interfere in events. Their goal merely to observe. So, more specifically, what that person is trying to do is to draw a conclusion about the population based on the sample. So, as we've said before, it's really difficult to impossible for a researcher to ask everybody in a target group that they are trying to talk about. So, if a study is involving Americans, can we ask every single American a particular question or ask them about their habits? No, we can't. That's impossible. To get to everybody? So instead, we have to rely on a sample. And that sample, if the sample is taken with enough care, there is ways for us to be relatively assured that what's happening in the sample is based on what's happening in the population. So we're going to get into the specifics of how we determine all of that. Oops. Okay. The biggest key there is that the sample should represent the population as best as possible. So think about Americans. If I want to make a statement or do a study involving people in the US, the people that I ask have to represent your average American. And so you need to make sure that you ask, males and females and whites and minorities and this ethnic group and that ethnic group and people in this bucket and people in that bucket. So whatever buckets that you feel are important, you need to make sure that you have those people in your sample. So when we look at the strength of a sample, we'll break it down into different categories and make sure that just about anything that matters, we have checked off some of those boxes in our sample. So that's one of the main characteristics of a good observational study. Okay? So the key here to the setup of an observational study. So let me extend this a bit and kind of write down a little bit about what this looks like. So let's see, let's do this and let's go to purple here. Okay, so in an observational study, generally, researcher does this. Researcher gets a sample. So research gets sample. Okay, and then what you'll usually do is you'll survey the sample. And to collect usually some sort of baseline data. So in the case of the breakfast study, the baseline data was their GPA before they started the experiment. And they looked at, what is the general profile of GPA? That's the thing I want to write about. So let's look at the general profile first. Okay, baseline data. And then also, what does the sample do? from there. So then think about breakfast, okay? We want to know or we want to examine what's happening when the students eat breakfast. So we then survey them to say, hey, are you eating breakfast on a regular basis or are you not? So the key there is the sample is telling the researcher on what's going on. And that's really kind of the major important piece that tells you that you're having an observational study. So, um, sample just does its thing. And the researcher doesn't touch it. And then at the end of the study, the researcher then does maybe another survey to see what's changed. The key there is the survey part. So the researcher just collects the information. Now, survey doesn't necessarily mean pencil and paper, like ask a question on a scale of 1 to 10. Like, yes, those are surveys, but survey is anytime you're looking for a response from the sample. So, again, the key there is the researcher doesn't do anything. They're just simply there to collect the data and report on it. Say, hey, this is the trend that I'm noticing. Anytime that you notice a trend in a group, whether it's, hey, I noticed that all the seniors tend to be leaving early. Why is that? That's an observation. Observational study could then go into, the reasons as to why, what affects whether or not a senior gets to leave early. First thing that comes to mind. But, you know, maybe you're in the cafeteria and you observe that, hey, it looks like it's mostly freshmen and sophomores that are ordering hot lunch. Gee, I wonder why. Um, or it looks like, for example, the fact and stats class, how we have juniors and seniors in stats. Why don't we have freshmen and sophomores? Those situations, we can notice a trend and then we can, explain it. Um, so there's lots of different um, ways to perform an observational study, but it all comes down to noticing and observing trends. Okay, so let's look at an experiment now. So the difference here, scroll back a bit. Experiment. Okay, so, okay, yeah, I use the word observe again. I'm sorry. But here's the difference. We are observing how a response variable behaves when one or more explanatory variables are manipulated. Okay, now you've probably never heard those terms before, but you have heard the terms independent and dependent variables. So you might remember from science how an independent variable is that thing that you manipulate, like you change in an experiment. And when you change that and you set that for part of your sample, it then may cause some sort of change to happen. And then that's your dependent variable. So, a great example of that is maybe sunlight on plants. So, let's say you have a group of plants and you have one set of plants that receive full sun, one group of plants that receive a little bit of sun, and one group of plants that you keep in a closet. Okay, well, that poor plant. I would feel bad for that poor little planty if it's in the closet all day. Anyway, I'm going to try not to do that. But anyway, the idea is you, as the researcher, change the amount of sun that's given to each plant. And when that happens, then the plant responds. And in that particular case, it responds by growing. Or if it's in the closet, maybe it doesn't grow so much, right? So the idea is that a response is what we would call like your dependent variable. And then explanatory is like your independent variable, right? So Why do we give them different names though? Why not just call them independent and dependent variable? The reason for it is because if we called it a dependent variable, um, it puts forth the assumption or the inclination that it is dependent, that what is happening in the response depends on what you do with the independent explanatory variable. However, we haven't done the experiment yet. We're trying to find out if that dependence exists. We don't know if they're related. They may not be. That's why we're doing an experiment in the first place. So we have no idea if one depends on the other, if the other one's independent. We don't know. So instead, we just call it explanatory and response. So explanatory is a better word because maybe it explains the response a lot, or maybe it explains it a little bit. It puts, I guess, more of the responsibility on the independent variable rather than the dependent variable. So now we just call it the dependent, we just call it a response variable because we don't know if it depends or not on the other variable. It's going to respond most of the time. It will produce a response. Now, whether or not the response is anything that we actually want to see is a whole different ball of wax, but it is a response. So when I um, apply sunlight to a plant, I want to know, does the sunlight explain how the plant grows? And the plant will respond by growing some amount. Whether that's related to the amount of sunshine it gets is, again, a different story. Okay? So we're here to try to determine whether that. Now, the person conducting the study is usually the one to introduce manipulation, but it doesn't have to be. We'll talk about that a little bit later on, something called blinding. So, but generally, though, the person who orders or conducts the study is trying to draw some conclusion about how the explanatory variable is affecting the response variable, and that's affect with an A. Guys, if I do anything with you this year, I am going to teach you the difference between affect and effect. And I am going to make it stick. Affect is the verb. Affect is when something is making the effect. I know, I just used effect. Effect is the noun. So effect, is the thing that happened. Affect is the actual happening. So we're going to work on that this year, okay? So essentially, this comes down to something that we're pretty familiar with, cause and effect. What you're looking for is you're looking to see if you can prove cause and effect, meaning can you prove that the explanatory variable is causing the desired response or causing the response that is noticed. I shouldn't say desired, just the response that we notice. Because if we can say that, that's very powerful to be able to say that. An experiment is used to determine cause and effect. Okay? The experimental conditions that the groups will be exposed to should be determined at random. So what does that mean? That means that when I have a sample and I want to then say, okay, I want some people in my sample to do this thing, and I want some members of my sample to do this thing, and some members to do this thing. The members that go and do each thing that I instruct need to be done random. Because the result is if they don't, if you just let the people decide what they're going to do, then people generally will do what they're most comfortable with. And then you have sort of a bias in that people you know, might automatically go to the thing that's going to get them the best results that they know. And so generally we're going to see different results. So the other thing is that, you might get a certain type of um, you might get a certain type of person to do a particular, treatment. So again, let's go back to the plant example, right? So suppose we don't determine them at random. Now you have some plants to get full sun, some that get partial sun, and some that get no sun. Well, there are plants that are good for each one of those types, right? So some plants need full sun, like dahlias. They need full sun. So if you fill your full sun group with dahlias and then partial sun, well, what needs partial sun? Oh goodness, what do we plant here? Um, I just know dahlias. Um, so what's the one that requires partial sun? Daisies, maybe? I don't know, I think we have some daisies. So, but anyway, if you give um, plants that are best suited for those types, then really you're not going to notice much results because they're all going to grow in an optimal fashion. Some plants don't require a whole lot of sun, and you could put them in the closet and might be okay. But that's not what is going to show good results. Okay. So what you want to have happen, the reason why really you want them to determine at random, is you want all groups to be about the same in characteristics. So if you want a little of everybody in each group. So another good example, if I have a random sample of, say, 100 students from Ellington, and I want to have them do a study, I want to make sure that when I split them into groups, that I have, say, males and females and freshmen and sophomores and juniors and seniors in each group. I want to make sure that I do that. And separating them randomly is the best way to do it because randomness will take care, if done properly, which is our next lesson, that will be taken care of for us. Okay, so let's look at our next bit. So, what are some examples of observational studies? Okay, so we've talked about a few of them, right? So, we've talked about, um, there is the breakfast versus GPA, observing, um, maybe observing students' meals at lunch. So, does like, you know, good food like nutritious food or fruits and vegetables or something lead to uh, better performance in after lunch classes. So, better performance after lunch. So, if a student eats a balanced meal at lunch, do they do better after lunch? That could be a good observational study. Or we could again think about, we could look at plants and say, hey, this plant's in the sun, this plant's not in the sun, and just simply observe what plants are happening when. Um, One observational study that I've done is I looked at, when I was in college, I did a study on this involving empty parking spaces in a commuter parking lot for my college, right? And um, I did a study, looking at the relationship of illegal parkers in commuter lots. depending on like time of day, what buildings are nearby. Like, so I was looking to say, is there a connection between like who parks illegally and what lots, or do illegal parkers prefer some lots more than others? So, I did that when I was in college. Um, what about experiments? We've given a couple examples. There's the plant experiment, like some sun, full sun. Um, we could do some experiments in terms of. Oh, here's a good one. Some students did a few years ago. We did perseverance in solving puzzles. And this is an interesting study that I had a couple students do. This at this point was probably 8, 9 years ago. Um, they had jigsaw puzzles, and they had two groups of people. They separated the groups, and they randomly decided, given a small little dollar store jigsaw puzzle, um, they decided whether they had to solve the puzzle right side up or upside down. And their question was, do people use visual cues on the puzzle pieces when solving, just a jigsaw puzzle? And so they had a little 20-piece jigsaw puzzle, and they randomly decided with each person what group they were in. Do they solve it right side up, or do they solve it upside down? And if you solve it upside down, all the pieces are white. And so they have less visual cues to help them solve the puzzles. And they found, as you can imagine, that solving the puzzle right side up, generally led to better results. So that's a good example of an experiment that we could do. And so you could come up with lots of other examples. Okay, so let's get back to the breakfast experiment. Okay, so we found that with the breakfast experiment, that people who ate breakfast 6% higher GPA, and then people who did not eat breakfast, some baseline value, 0% growth. Okay, something like that. So we had that result that happened. So people who ate breakfast exhibited a 6% GPA, higher GPA than those that did not. So here's my question. Does that mean that breakfast caused it? No. Well, we can't prove it, can we? How can we prove that it's the breakfast that caused the increase in GPA? Can we track whether or not the breakfast provided nutrients to the brain? No. So what we do is we think about what those people like that ate breakfast, is there anything else that they have in common? If we can find something else that those people have in common, we call that a confounding variable. So, um, what else about people that eat breakfast? Well, who are the people that eat breakfast? They are people that are managing their time well enough that they can get up, have the time to eat a good breakfast. These are the same people that would then more likely to manage their time for studying and can, budget their time well during study halls. They can make it to school on time. They're not rushing to get out the door. So it turns out the people who eat breakfast generally are people that have good habits. Maybe it's those good habits that lead to an increase in GPA. That's called a confounding variable. And at that place, we don't know whether or not the people who ate breakfast, whether it was the breakfast or whether it was other things. So this is basically variables and conditions that are related to the group membership and the response being measured. So the idea is it's a variable that sort of serves like a middleman, and we don't know which it is. Okay, good example. Many studies have said that people who take multivitamins tend to be healthier. Well, why is that? Well, let's think about it. People who take multivitamins, if they take a vitamin, they care about their health. They care about their health, they're more likely to think about exercise. They're more likely to do other things as well to be healthier, not just the multivitamin. And it's those other things that are confounding variables. So, in this particular case, we could say just any other healthy habit. Exercise or what have you, sleeping well. Here's another good one. Um, Patients that are recovering from a heart attack and own a dog have better heart rate variability than patients who do not own a dog. Okay? So they looked at a study of heart attack victims and how trace their recovery. And they were finding that people who owned a dog had better recovery and recovered faster than those that did not. So just the fact that the dog exists makes people's hearts better, right? Oh, that's clearly, right? Clearly it's the dog. Or is it the fact that dog owners get more exercise because, they have to walk the dog, and dogs do require more care and more, playtime, things like that. So you're always out with your trusted companion, walking them, playing with them. They get more exercise. So maybe that's the reason why they're getting better. So is it the dog or is it the exercise? My money's on the exercise, really. So when you see this sort of situation come up, oh, confounding variable, maybe you have to decide whether it's that variable that's really kind of the true reason. Okay, here's another one. This one's a little bit wacky, but a fun one. Some studies have mentioned that left-handed people have a lower life expectancy than right-handed people. And current data suggests, well, this data is a little bit old, but worldwide, a composite average of 66 for left-handed men versus 75 for right-handed men. Wow. Okay. So what gives? Why would left-handers, they did this study and this is what they found. They found that people that were left-handed had a significantly lower life expectancy and lived far less years than right-handed men. Or did they? If you do the study like that and actually look at and follow left-handed versus right-handed, you're not going to find a difference. But what they were doing is this conclusion was based off of a incorrect assumption. So what they were finding is that at every age group, 0 to 12, 13 to, 13 to 49 or whatever it is, 13, and I'm just picking numbers here, whatever it is, all these age groups, all the way up to 65, all the way up to ages 65, every age group, every category, every minority group, every ethnic race group, every gender group that they looked at is always floating somewhere in the 12% left-handed rate. So no matter how you break it down, um, left-handedness occurs in about 12% of the population. However, when you get to age 65, that becomes 3% left-handed. And what was happening is they were using that to surmise that once you get past age 65, that all those left-handed people are just dying off. Clearly, um, must have a lower life expectancy because there is far less of them alive. Comparatively speaking, we're losing um, what ultimately ends up being almost three-quarters of them. Okay, so is that true? No. I mean, other than what, accidents with lefties trying to use right handed things? Listen, I'm left handed. I can understand maybe that, but really, is we learn pretty quickly how to adapt to right handed tools. Um, and for many of us, especially me included, because I grew up around right handed people, I learned how to do a bunch of stuff with my right hand too. Um, so actually, I can better cut scissors with right versus left. Okay, using scissors. And there's two things actually: scissors and um, baseball. So swinging a baseball bat, I swing like a righty. But that's because they learned baseball around right-handed people. Anyway, so side note there, but that's the idea. Is we're thinking like, well, why does this data exist? So, what is the confounding variable that's causing this? Catholic school. Most, a large proportion of people, I shouldn't say most, but a large proportion of the people in that 65 plus age group um, there was a much greater proportion of them that went to Catholic school. And not only that, but at that time, so if they're over the age of 65 now, then they were in grade school back in the 60s, 70s, right? And at that time, and prior to that, it was very commonplace um, to ensure that people were right handed. It was, believed that left handed people were agents of the devil. And if you attempted to write with your right hand, with your left hand, you got smacked, either rapped on the hand or just outright paddled, and you were compelled to write with your right hand. Um, that was kind of the, you know, godly, good way of doing it. And they don't do that anymore. Even Catholic schools nowadays, they have really given up that practice. And so you don't really see that anymore. And ultimately, what's going to happen is in the next 25 years, or probably even sooner than that, I would say, you're going to find that this is going to vanish as um, the older generations that had significant attendance at those types of schools, as that dwindles. Once you get to like the 70s, 80s, um, public school kind of became the thing for most people. So, and then once those rules went away, you're all of a sudden going to revert back to that 12%, no matter what age group, no matter what subgroup of people you look at. So, this difference is about to go away. Confounding variables come out in a lot of different ways. Okay, so let's make a conclusion from a study. So, what do we do with it? We did a study on student GPA versus breakfast, right? Is it an observation or an experiment? Okay, so did the researcher just survey and watch the people, or did they make the people do things? Okay, so what would that look like? In this study, for an experiment, they wanted to know the effect of breakfast on student GPA. That means breakfast must be your explanatory variable, and student GPA must be your response variable, your independent, your dependent. So, in this particular case, then, in an experiment, the researcher would have to assign people to eat breakfast or to not eat breakfast. Well, that doesn't sound very ethically good, right? Ethical. That's the word I'm thinking of. Duh. Ethical. That doesn't sound very ethical. Forcing people to not eat breakfast or forcing people to eat breakfast. like change their habits all up. I mean, sure, if they want to volunteer to do that, that's one thing. But coming in here and, flipping a coin, being like, nope, you are not going to eat breakfast for 3 months. That seems a little, yeah, like tough to pull off just in this kind of a study. So it's an observation. The researcher just simply asked if, or collected data, if they ate breakfast or not. Okay. Did the researcher randomly assign students to breakfast and no breakfast groups? Nope, certainly not. So therefore, it's an observation. Oops. That's not quite what I wanted. Uh, can I, tap it? There you go. Okay. Not moving here. Okay. So, uh-oh. There we go. Did the researcher assign it to breakfast groups and no groups? Uh-oh, why are you not scrolling anymore? Let's delete that. Okay. I know. It's having some issues. Okay. Okay, yeah, it's starting. Oh boy, this is starting to get funky. Okay. Um so let's try to wrap this up pretty quickly, right? So it's an observation. Now, here's the thing in an observation. One of the big things that you're going to learn about observations is that, okay, so we're having some technical difficulties. My slides are starting to disappear. Okay. So um, when this happens, there's a couple things I can do. Oh, okay. So let's see if this does it. Okay. So here's the thing. Um, in an observation, when you're simply observing, you cannot determine cause and effect at all. So, in an observation, whether or not you have a random sample or whether you just have some convenient voluntary sample, whether you have volunteers, it doesn't matter. You cannot determine cause and effect. Okay? Repeat it with me, folks. There is no cause and effect in a observation. You cannot determine, even if you see a very obvious trend, you don't know that that variable is causing the results that you see. Now, without an experiment, because you don't know what else those people with that effect, what else they have in common, not without getting deeper into more information. Now, that being said, an observation is useful to generalize the group to the population. So let's look at that breakfast study. So they found that the people who ate breakfast had a 6% higher GPA growth. Now, you can then look at those samples. If those samples were randomly chosen, okay, if those people that participated in the study were randomly chosen from that school and they exhibited that GPA growth, then you could comfortably say that the whole school would have experienced the same GPA growth. And that's because a random sample tends to be uh, the same as the whole school. So, random sample, and we're going to learn about this a little bit later on, um, tends to be representative of the population. So, think about this in our school building, right? So if I were to just go to the main office and pick 50 random students from all over the building, I'm probably going to get a little bit of everybody. I'm going to get some males, some females, upperclassmen, underclassmen. I might get people from all different kinds of backgrounds in the town. Um, so I'm going to get a little of everybody, most likely. Now, in an experiment, so let's see what's happening um, in an experiment. Oops, still not acting right here. No. Okay. Let's try that again. Hold on a second. It's got to load. So unfortunately, just a little bit of a hiccup there. Okay, here we go. Oh, and it scrolls now. I'm not sure why it does that. So in this particular case, if we look at this, we already said that no cause and effect, right? No cause and effect for observations. That's important. But let's look at an experiment. Say you have random assignment. Now, random assignment means that you are randomly determining who is in what group in your sample. That's when you get the cause and effect. Okay? And if you pick your people at random and you then take those random people and assign them randomly, then you get both effects. You get the effect of not only can you tell that that variable that you're studying caused the desired or caused the observed effect, but then you can then take that result and then you can generalize it to the entire population. That is what we call a well-designed experiment. Now, if you have random assignment, like you're able to take your population and randomly assign them to the different groups, but they're not random subjects. Let's say you got some volunteers, or let's say I'm doing an experiment like that just within stats class where you're not random, you're in my classroom. What would then happen is I could determine with a proper experiment whether or not that variable is causing the noted effect, but those results would not be able to leave my classroom because you're not random. You said, well, you're in my classroom. There must be a reason why you're here. Maybe that reason is causing part of that effect, is part of that reason. So we can't, in that case, generalize to the population. So the only time you can take the results from your sample and bring it out to the population is when you have a random sample. And then cause and effect only happens when you have what's known as random assignment. Have both of those, you have yourself a good experiment. Okay? And that's really how it goes. So in class, we will go through and look at how we can tell the different pieces here and there of what's an experiment. So versus an observation. So remember, the big difference between observation and experiment is what did the researcher do to collect their data? Did they just ask the people what they were doing? That's an observation. Or did they actually tell the people what they should be doing and then collect data? That's an experiment. Okay? That's the main difference. So we'll go over some more of that as we go through in class, okay? But I think we're going to leave it here because my system's starting to act up. So have yourself a lovely evening, folks, and I'll see you soon.